the physical and the engineering information with also Siemens MindSphere environment for the IoT, and to have this together, PlantSight be able to provide plant owner operators with a quick and easy incremental service for whatever their existing environment is for their operating plants, and to provide a very quick return on investment. I know at the conference we've heard of challenges and the questions of where to start in going digital, and we think the answer is with a as-operated digital twin cloud service. It's PlantSight from either Bentley or Siemens.
I've spent most of my career in the process industries, and I have seen how hard it has been to pull together information from the many different silos of data that exist to support process plants and process industries. You've got data stored in engineering modeling systems that are used by the engineering firms to design and construct process plants. You've then got data stored in the maintenance systems and the ERP systems that is used to control the workflows to maintain and operate the plant. And then you've got a whole pile of other data within the SCADA systems and the control systems and the historian systems about how the plant's actually operating. And for the longest time, this data has been held in completely different silos, and it's been really hard if you have to debottleneck the plant and figure out what is causing a problem, what is causing an issue, where you could improve the plant efficiency, plant safety. It's so hard for the engineers and the operations and maintenance people to pull all the information together and figure that out and make good decisions. It takes way too long to find information, and worse, when there is a change done, it takes way too long to update all of the other systems that need to know about this change. So consequently, the systems that people rely on quite often don't have accurate data, complete data, or sufficient data in order to make good decisions. And this is where digital twins now become so important, because a digital twin is an accurate, evergreen reflection of what you physically got going on, pulling together all of the real-time operations information, all of the information about the work processes going on for operations and maintenance, and also all of the up-to-date engineering information that you've got. It's no longer buried in these old design systems with technologies such as reality modeling, coupled with the tools like OpenPlant that we have. You can keep the engineering information bang up to date, ensure any changes get reflected immediately, and pulling all of these things together, you get a really solid digital twin of your process plant, and therefore on which you can make good operations decisions, maintenance decisions, upgrade, revamp, debottlenecking decisions. So, having looked at the challenges of pulling all of these data sources together, Bentley's working with Siemens, and we have created a solution, a cloud-based solution called PlantSight. We are pooling the knowledge of Bentley on the engineering, design, construction side, and Siemens on the operations maintenance side, pooling those two sources of knowledge together to create a cloud-based environment called PlantSight that delivers digital twins for the process industry from an IT perspective quickly, efficiently, and inexpensively, so that all process industry organizations can benefit from having digital twins immediately with the information that they've got. What makes PlantSight different is a combination of Bentley and Siemens knowledge that has gone into this, so we have all of the bases covered, but we've also got that approach to being very open to pulling data from any sources in, using international standards, using international connectors for this data. The underlying technology or the underlying data architecture will pull data in from any system. A lot of our competitors say you can only have a digital twin if you put all the data within the same architecture and system, data store if you like. Bentley and Siemens believe in a federated data model where you align data together and you can pull data from any data source. So having that openness to open interoperability, openness to pulling data together. The other thing that I think differentiates us significantly is the ability to capture the as-is conditions using photogrammetry and or laser scanning, being able to pull that information in, the non-digital data, if you like, in from the existing plants. I am not sure I know of any other competitor that really can do that like we can.
Digital twins give us a digital representation of a physical asset, process, or system, as well as the engineering information that allows us to understand and model its performance, from 6 months to just 1 week. Typically, a digital twin can be continuously synchronized from multiple sources, including sensors, and continuous surveying to represent its near real-time status, working condition, or position. A digital twin enables users to visualize the asset, check status, perform analysis, and generate insights in order to predict and optimize asset performance.
So we're coming to market now, we and Siemens, with our jointly developed plant site service. It is a digital twin cloud service for operating process plants. And we together looked at what are gaps in the market, how can we help most. Plant site enables the digital twin environment to be created and curated very quickly and practically. It's, after all, a twin. It reflects the digital components and the digital in their digital context. So as a twin, it doesn't displace or replace anything, and every operator of a plant can now add a digital twin cloud service. That's what PlantSight caters for. And what we've been able to do with Siemens is create a brand new web native environment with the interface you would expect of a cloud service that's intuitive and doesn't need training, and which provides the immersive visual experience of the twin of the plant, but has access to the engineering information in the quality and usefulness of schema that we and Siemens could create by bringing together our experience with Comos on the functional side in the Siemens case, and our open plant 3D experience, and having access now that we've brought together the physical and the engineering information with also Siemens MindSphere environment for the IoT, and to have this together, PlantSight be able to provide plant owner operators with a quick and easy incremental service for whatever their existing environment is for their operating plants, and to provide a very quick return on investment. I know at the conference we've heard of challenges and the questions of where to start in going digital, and we think the answer is with a as-operated digital twin cloud service. It's PlantSight from either Bentley or Siemens.
Hello everyone, and welcome to the Bentley Systems webinar. Think big, prove small, scale fast. Brought to you in association with Oil Review Middle East, the leading oil and gas magazine for the Middle East and North Africa. This webinar will highlight how the open approach to digital twins can drive big benefits for the oil and gas industry at a time when it's facing a perfect storm of challenges, ranging from cost pressures compounded by the impacts of COVID-19 to the need to reduce emissions and carbon footprint in line with climate change commitments. For those of you unfamiliar with Bentley Systems, it's the leading infrastructure engineering software company, providing innovative software such as microstation-based applications for modeling and simulation, project-wide for project delivery, asset-wide for asset and networking performance, and the iTwin platform for infrastructure digital twins. The company employs more than 4,000 people and generates annual revenues of more than $700 million in 172 countries. I'm Louise Waters, editor of Oil Review Middle East, and I'm delighted to be moderating this timely webinar today. Well, the benefits that digital transformation can bring are well documented now in terms of efficiencies, cost savings, enhanced safety, better decision making, etc. Digital twins offer better planning, delivery, operation and maintenance of infrastructure assets, as we will hear. And the benefits of digital transformation can be huge. Abu Dhabi National Oil Company, ADNOC, for example, claims to have saved $1 billion so far through its digitalization transformation program. But I think it's fair to say that the pandemic has really brought digital technologies to the fore. Indeed, they've been all but indispensable in ensuring businesses can continue to operate and people can continue to stay connected. There's a growing realization that digital technologies are not a nice to have, but rather a critical enabler for future success. So, over the course of the next 45 minutes, we'll hear all about the digital twin, how it can drive value across the life cycle of assets, and how to make it a reality to bring you the best results. We'll hear presentations from 3 speakers, all experts in their field. Alistair Stubbs, VP Asset Information and Reliability at Bentley System, Josh Edkins, Digital Transformation Manager, Shell Deepwater, and Mehreen Javed, Digital Integrator, Business Development, Plant Site at Bentley System. Alistair will be setting the scene for us and introducing the digital twin, the huge range of benefits it can bring, and the challenges in building, sustaining, and using a digital twin. Then we'll play a presentation from Josh Edkins, who will discuss how energy giant Shell's Deepwater division applies Bentley's iTwin platform to streamline and drive efficiencies in its capital projects. And finally, Mehreen will show how Bentley's Plant Site makes the benefits of the digital twin immediately accessible, unlocking value for users and enabling them to start their digital transformation journey at any stage in the life cycle of the asset. She'll discuss some further use cases covering the fields of design, construction, operation and inspection. Following the presentation, Alistair and Mehreen will take questions for around 15 minutes. So please leave any questions in the Q&A chat box below your screens. So just before we start, let me give you a bit of background to our 3 speakers. Alistair Stubbs, VP Asset Information and Reliability at Bentley Systems, initially qualified as a ship scientist from the University of Southampton. Since graduating, he's worked as a marine consultant, spent 13 years with the Lloyd's Register and ran his own businesses. The majority of Alistair's career has been spent developing, implementing or supporting information management solutions, predominantly in the marine and oil and gas industries, promoting the benefits of information management across the asset life cycle. In his work, he's seen both the positive transformative impact that the application of technology has brought to many businesses, and he's learned the issues that prevent the realization of value. Alistair is currently working as a Vice President for Bentley Systems, where he's focused on the benefits that the asset-wide solution and digital twins can deliver to many industries, including oil and gas. Our second speaker is Josh Edkins, Digital Transformation Manager at Shell Deepwater. Josh leads Shell's Deepwater Gulf of Mexico digital transformation across the full life cycle and all disciplines, including strategy setting, standing up effective initiatives in place of government, operationalization, value tracking, transformation of culture and ways of working, and staff upskilling programs. Additionally, he serves as the Shell Global Value from Data Community of Practice Lead, bringing staff from diverse projects and assets together, innovate, share and replicate successes, and support each other in solving intractable problems. And Mehreen Javed, Digital Integrator, Business Development, Plant Site at Bentley System, has over 18 years of diversified experience designing, architecting and developing software products for the plant domain. In her current role, Mehreen works closely with users to reimagine their existing workflows and interactions to deliver maximum impact by leveraging the digital twin technology. Ladies and gentlemen, I'm sure we can look forward to a very thought-provoking and informative hour packed with insight. So without further ado, let's turn to our first speaker, Alistair Studd.
Thanks, Louise. I wanted to start the webinar by discussing what we mean by digital twin. It's a term that's become overloaded in the industry and has lots of different meanings. But fundamentally, what we're talking about when we discuss digital twin is enabling an organization to build a virtual replica of their operating asset. That replica is connected to that asset so that it constantly reflects what's happening in reality, whether that's at an engineering level, the design, the configuration, and the assembly of the plant, if you like. Whether it's the operational aspects, it's connected to the data and the systems that are controlling and managing the plant to give real-time insights to the actual operating performance on an ongoing basis. And of course, it is connected to the various different systems that provide the information about the plant, whether that is the maintenance systems, the ERP solutions, or the registers of information about the assets that make up that plant. And really, a digital twin has been assembled historically, it's been built for a purpose and then discarded. And really, a digitalization strategy built around a digital twin changes this and says that actually we want to maintain that digital twin continuously so that it's always available and we can use it as a window into the real operating plant from anywhere in the world. And of course, that means we're looking to consume the information in that digital twin in the different ways. And on the right-hand side of the slide, you can see we're highlighting the ability to use 3D visualizations to link to a timeline of change, so you can see a history of change either in the operating parameters or in the physical configuration of the plant. And of course, the ability to connect to this continuous stream of operational data that is coming in from all of those, from the IoT sensors and the control systems, that gives us the opportunity to apply new techniques that are just evolving in the industry, especially around artificial intelligence and machine learning, that really unlock additional insights into the real performance and the asset of the plant. So digitalization is an agenda for many of our users in the oil and gas industry and the process plant industry. And the digital twin is one aspect of that. And Josh will be speaking a little bit later about some of the other aspects around the cultural change and the organizational change. But of course, there's every asset app has got many different stages and points in its life cycle. And the digital twin is applicable across the across the life cycle of the complete asset, whether it's engineering for a greenfield project or re-engineering for a brownfield change, whether the asset is in operation or is still just being designed, and various different options are being evaluated. Of course, a digital twin is incredibly valuable when undertaking maintenance. Imagine the ability to be able to see the real operating performance of a piece of equipment just prior to it being maintained, and especially being able to see the operational performance of that from a safety perspective, just as you're about to undertake maintenance, and being able to validate things like permits to work, shutdown procedures have all been executed safely. Another really interesting aspect of a digital twin that we believe is important is that you're able to continuously survey it. So not only are you seeing the inputs coming in from the performance and the operating aspects of the plant, the control systems, not only are you getting information from engineering change, but you're able to continuously validate that those changes and all aspects of the plant using reality capture to build a living and continuously surveyed model of that. And that can also be integrated with the registers of information, the schematic information, and of course the 3D model. So the digital twin works wherever you are in your asset lifecycle, and is, as mentioned in the introduction, has delivered to many operators in the Middle East region significant savings already through pursuing this strategy. But it sounds ambitious, but it needn't be. If the value is significant, then how do I get to a point where I'm benefiting from a digital twin? And the image here is meant to show that obviously it's a climb to the top, but it needn't be an arduous one. You can see, you can just walk to the top of this mountain, and really that's what we're trying to do. We're trying to work out how we can unlock the value of a digital twin that forms part of a broader digitalization strategy as simply and as quickly as possible. So our users are talking to us about 3 different challenges that they're seeing in building a digital twin or in operating a digital twin. The first is, how do they take the information that they've got and create that digital twin in the first place? How do we go from no digital twin to a complete digital twin? How do I do that for a greenfield project that isn't built yet is very different to how do I do that for an asset that is in operation and possibly has been in operation for 20 years or more. The formats of information for legacy assets will be varied. Quite often will just be paper. But if the benefits of a digital twin are so great, how do we build and get to that point of a digital twin with the information I've got today, in the quality that I've got today, so that I can do the best I possibly can? So really the big challenge, how do I create that digital twin with the information I have today? Having invested in building a digital twin, an awful lot of its value comes from your ability to be able to trust the information that it's telling you, to know that it's accurate and that it's up to date. And therefore, we need to be able to put in place the business process change and the supporting tools in order to sustain that digital twin. How do I assure that the information that is in there is accurate and is up to date? And then finally, if I've built a digital twin, if all of this information has been assembled, I've got a window into the operating performance of my plant. I can see all this information. I can get and easily access the data in that digital twin. Then where do I start? What is the best place to start, and what's the biggest benefit I can get from that investment? So again, how do I use that digital twin for the benefit? And I'd like to just take a few moments here just to talk at a high level around each of these different use cases and give some suggestions for ways to start. And then Josh and Maureen later will go into some more detail about these areas. Let's start with building a digital twin. Our users are telling us about the importance of digital twin as part of their strategies going forward. But they're also telling us that they've got information that is in many, many different formats. They recognize that they want to get started, but they struggle with information that is in legacy formats across many different systems, often just in paper, and they want to avoid having to recreate all that information and really start out on the digital twin journey. And we think that there is a really key message here. We think that openness to these multiple different formats is something everybody in building and embarking on a digital twin story needs to focus on. Because no matter who's building the digital twin, what industry you're in, the information you're having to consume will come from myriads of different sources. There will, of course, be engineering sources in many different formats, but there will be operational data coming from many different suppliers. There'll be equipment and vendor information from many different OEMs. And the important value of the digital twin is being able to bring this together and to unite it into a single whole. So therefore, openness, the ability to work with these different myriad informations from all sorts of different formats, information formats that are legacy and have been around for a long time, 20, 30 years, but equally importantly, openness to the future as well, for new formats that will be being developed in the industry and new systems that will be implemented in the future. So Bentley believes that openness is key, and our users are telling us this. They appreciate the open source nature of the solutions that are being built. They appreciate the open access to the data through different APIs, and importantly, data openness as well. Not all systems are built in a single solution, and as our supply chains get more complex, either in construction or in support, we're seeing many, many different formats, even in ostensibly a single modern greenfield project. So Bentley's invested heavily in this. Obviously, we support Bentley's design applications, but a very wide range of third-party design solutions from all the major players in that space. And equally, an awful lot of investment has been made in third-party interchange formats here, with standards like IFS, legacy standards, if you like, or long-lived standards, and important new standards that are developing and evolving in the industry, such as CFOS. Moving on to the second element, the sustainment stage. We're having invested in building a digital twin, what we're seeing is people struggling to maintain that digital twin and getting the assurance that it's up to date. So where the investment has been made in that twin, it's been integrated with the operations. The value comes from having the confidence that you can use that information reliably, not just local to an asset or a plant, but remote from that asset and plant as well, possibly on the other side of the world, engaging with OEMs to solve problems from many different locations. And we're also finding that if we're starting with a brownfield asset, our users are building digital twins based on the information they have today, and then continuously improving that information within the digital twin. So they're starting with a digital twin, they're getting it as good as they can, and then as a result of the change and the ongoing work, they're embarking on a journey to continuously improve it. So they're starting with a partially complete twin, and then iterating on it to continuously add information and make it richer, broader, and deeper. And we think this is a fantastic way to begin to unlock the value that users see in a digital twin. We think one of the key aspects to this is an effective information management strategy. This is a business process. You'll see it called change or configuration management, and many organizations already have this. But integrating it with a digital twin is something our users are saying is a critical success factor. And especially going into your supply chains, being able to consume information once and reuse it across one or multiple assets in your entire operations. We're seeing, as digitalization accelerates, the focus on information management as a discipline within your organization that exists to assure and continuously improve the quality is ever more important. Our leading users are adopting digital twin technology and using it to continuously assess their plant, to take readings from operations, but also, and importantly, to continuously improve their information quality, identifying gaps in their information sets, focusing using risk techniques on areas where they want to improve. If you like, we're seeing increasingly advanced users take this information management discipline and treating it, if you like, as the maintenance management system for their virtual twin, for their virtual asset, like they have a maintenance management system for the physical asset. And keeping these two in sync is proving to be extremely valuable. This Boston Square illustrates many of our users' situations where typically we find on the horizontal axis, information is in many different places, very difficult to access. On the right-hand side, it can be found, and then vertically, the level of completeness of information, where at the bottom where it's incomplete and at the top where it is complete. And obviously, our objective is to move from the bottom to the top and from the left to the right. And digital twins are enabling our users to easily identify where there are gaps in their information. And of course, to pull that information together into a single window that enables them to access it from anywhere in the world through just a web browser. And that is unlocking immense value. Within the region, I'd highlight a use case from BP where they've used Bentley technology to ease handover as a project in Kazan went from the greenfield into operational phase, and that operational readiness step was critical. And because BP had invested in building a single integrated information set, pulling information from a myriad of different sources, they were able, in the project phase, they were able to hand over a very complete information set as a digital twin to their operations phase. And then they embarked on a journey to augment it with, as part of their operational readiness processes, to fill out all of the data that was needed in there. As a result of this, they cited the use of this approach and this technique, that the combination of information systems with their business process change wrapped around a digitalization agenda and the digital twin. They cited this as being critical to them starting production ahead of schedule. Their users are reporting significant reductions in the time it takes them to find information. They almost eliminated data exchange between project and operations. And the coordination in their supply chain as they send information out, deal with queries and such like, is dramatically improved as well. Let's move on to the use case. Having built a digital twin, having assembled that information and got a complete picture, how do you use it for maximum benefit? And I'd like to highlight two scenarios at this stage. I'd like you to imagine the operator in the plant undertaking work. And imagine a scenario where they are able to approach a job, a task that's maybe set up in their maintenance management system, but through the digital twin have access to the complete history of that plant, the complete information about the asset that they're about to do some work on, whether it's the schematics telling them where that is built and its role in the entire process, detail of the last previous inspection that was done, maybe by a third party specialist inspector, or have access to OEM documentation, all at just the click of a button on a web through a web portal. Being able to pull that together to drive efficiency, to get the work completed correctly and done first time, and importantly, to get it done safely. And then the ability to integrate with that and feed back the results of that work into that digital twin so that it's updated and it's ready for the next user when it's next needed. It's a fantastic time saver. It's a huge improvement in risk and safety. And it helps you to continuously evolve and continuously improve your digital twin. Equally, the management of a plant and an organization needs the data that's in the digital twin to help them make their business decisions. The ability to do that much more dynamically with confidence based on the information there is significant. And there is significant improvements in the safety, the ability to demonstrate compliance, the minimization of risk. The opportunity is there to use this information, as Louis said at the beginning, to reduce costs significantly and the total cost of ownership of that asset, which of course gives you a much bigger return on your investment. And then of course, we have the ability, the improvements made in reliability and resiliency of your operations, the processes that go together to enable you to run your plant, and the reliability of the physical asset itself will improve. So that gives you an operating efficiency improvement. It's critical. The digital twin forms a foundation, if you like, of many digital transformation stories. Here, I'm going to just highlight ArcelorMittal. They achieved very significant maintenance savings in this case in over a period of 5 years. They pulled together, again, information. They connected their operational assets into their digital twin to get real-time readings. Very heavy industry. They used reliability solutions and a reliability approach strategy as well, and lined that up within the context of a digital twin to drive very significant savings and operational insights into their businesses. In excess of $14 million of savings over 5 years. A really significant reduction in downtime, which drove further savings, but of course boosted their reputation in the industry. They made savings across their entire supply chain, not just within the plant, but by adopting this progressively across their entire supply chain, their vertically integrated operations, they were able to save even more, easing the entire workflow from beginning to end, the entire process from beginning to end. So at this point, I'm done, and Louise, over to you.
Thank you very much, Alistair. That was a great presentation, covering not only the benefits of digital twins, but also how to navigate some of the challenges and some of the important considerations, such as the importance of adopting an open approach and the importance of information management. So now let's move to our second speaker, and that is Josh Atkins, Digital Transformation Manager at Shell's Deepwater. He will discuss how Shell's Deepwater division applied a digital twin approach to streamline and drive efficiencies in its capital projects. And before we start, can I just remind you, please do keep your questions coming in the Q&A box at the bottom of your screen. Thank you.
Thanks to Bentley for having me today. I'll dive right in. I'll talk about 3 challenges. The first is change management. The second one around document-based collaboration models. And the third, workflow transparency. The first on change management. In an effort to reduce the time and cost of our mega projects, we often have some of our engineering work happening in parallel with other project work. And what we find is that it's not that uncommon for highly consequential new information to flow into a project midway through. And that can trigger a cascade of changes that can impact many different teams, both internally and externally. Next, on document-based work, we're relying on documents to transfer data and information between our internal and external teams. And that's causing problems and opening us up to version control issues. Third, on workflow transparency, with the energy transition in full effect and actually accelerating, Shell is in this on this long-term journey to cut costs, reduce our greenhouse gas footprint, and of course, improve safety. Well, we've been on this journey for some time, and we've made great strides, both in the capital cost sort of reduction phase and also the operational cost reduction phase for our assets. The next big opportunity for us is to radically reduce the amount of time it takes to come up with concepts and select those concepts and then trigger the engineering work all the way through to construction and then asset startup. So we look for a lot of different solutions in the marketplace to resolve some of these issues for us. We scanned many different solutions. We found that the Bentley solution offered an open architecture, and that allowed us to be more flexible to collaborate with many different external partners, Bentley, Futuron, and others included. And it also enabled us to map in many different internal systems and processes and data flows. And as a result, in partnership with Bentley, we've been able to build like an end-to-end workflow that's completely orchestrated. And it's within a platform. So we're able to map the dependencies in this platform between the engineering work that has to be done and the key decisions that have to be made to advance that project from a twinkle in our eye to a fully producing asset. So on the document-based work, to move from document to a fully data orchestrated workflow, it requires a transformation that is as much about culture and behaviors and willingness to learn, more so than it is about tools and technology. But certainly the technology is an enabler. So having all of our work occur inside of this platform, we can actually see how long it takes to complete each different step. We can benchmark across projects, across time. We can also begin to innovate not just on the designs of what kind of equipment we're putting in place. We can actually begin to innovate on how we get the work done. That's going to allow us to reduce the amount of time it takes to get through these processes. So how much time? We're looking to trigger a roughly 30% reduction in the amount of time it takes us to come up with concepts and select them and move into the engineering phase. A concept engineer can now take a concept and kind of rough it up in 3 dimensions within this platform. And they can do 2, 3, 6, 10 different concepts within a couple of minutes, as quickly as they could drawing it on a whiteboard or mocking it up on a PowerPoint slide. The magical aspect of this is now all of the cost and schedule data is connected to those standard engineering packages in 3 dimensions. So with the click of a button, we're now able to actually identify and calculate and visualize how all of those different solutions stack up against one another. So you'll have professional looking waterfall charts that show the cost and schedule comparisons. And that makes the concept selection process quite simple. What used to take us months to do is now can be done live. So when we demonstrate this to our leaders, there's smiles all around. So next on the workflow transformation, how are we doing it? Well, we've got a product owner that's coming in from the business. So these are people that are really working on designing and building these assets every day. And we're complementing that with some of the best capabilities from across Shell. So we have our Agile Hub, our Digital Center of Excellence, our IT, our research and development, and also the capabilities that are coming in from Bentley and from other external partners. We're working in an Agile approach, and we're placing a lot of importance on dedicated resources so people are not multitasking against many other competing resources or requirements. And we talk on these teams as much about cultural transformation as we do about digital transformation, and that's making a big difference. We've also got access to the most senior leaders in Shell. So when we see issues popping up, we're able to eliminate those issues and get things moving very quickly. And so that's allowing us to move from concept all the way through to engineering much more quickly. So really today I've only spoken about one of the many different things that we're working on within Shell in this digital twin and transformation space. So there's many other things that are going on right across the globe that are also across the asset life cycle. So we have projects, because of this, we get projects delivered faster. We have construction happening more safely, and we're having assets delivered with fewer defects. We're extending the life of our assets with structural digital twins and carrying that into an ability to basically cream the best part of that value curve. And we're reducing manning, increasing uptime and efficiency, and of course, reducing the environmental footprint, not just of the asset, but the entire value chain that's connected to that asset and the supply chain. So in summary, the digital twin is enabling a streamlined partnership to deliver better together.
Great, that was a really good presentation from Shell there. And it was really obvious how the use of digital twin is driving big benefits for Shell Deepwater's operations. Okay, so let's move on to our final presentation, and that's from Mehreen Javed, Digital Integrator, Business Development Plant Site at Bentley Systems. Mehreen.
Thank you, Louise. Over the next few minutes, we'll see some exciting applications of our digital twin technology and get a glimpse of how leading organizations around the globe are using digital twins to design, construct, operate, and maintain their critical assets. With plant sites, a quick reminder, you can start your digital twin journey at any point of the asset lifecycle with the information that you have today. As we know, the vast majority of revenue in the oil and gas sector is earned from brownfield assets that have been in operation for decades. With PlantSight, you can leverage all of your existing engineering data and asset management systems and aggregate them into a digital twin of your brownfield facility. You can set up powerful dashboards and reports, leveraging the power of the Azure cloud, and monitor your facilities, gather insights in a web-based portal. If you don't have an existing 3D model, you can create a 3D reality mesh with laser scans and 2D images. Here you have a reality mesh of an entire plant created from images captured by a drone. These images are then processed in our context capture tools and then classified to tag and identify key assets. This now presents a visual context for your digital twin. You can now start associating attributes and other intelligent information and also link them to your existing asset management systems. For brownfield assets, PNIDs are typically available only in unintelligent formats. As seen here, using our integrated AI and machine learning tools, you can find assets on scanned paper PNIDs with just a click of a button. If any symbol such as this pump, which is created with a dotted dashed line, is not recognized in the underlying machine learning model, it can be trained to easily identify it, not only on this, but also on all other documents. While many companies are currently spending days having designers painstakingly recreate each of these documents in a design application to make them intelligent, our tools here complete this task in mere minutes. This technology makes the benefits of a digital twin immediately accessible to existing plants and unlocks latent value for our users. As you can see here, once an item is classified, it can easily be recognized. By aggregating this output with PlantSight and AssetWise, we provide owners and operators a solution to realize their digital twin and empower them and their teams to make informed decisions and take corrective action. It integrates with your existing predictive analytics and performance management systems, so you can get both real-time and historical sensor data as you monitor and react to alarm conditions. And you can also initiate work orders directly from this environment. Digital transformation at its core is about change, and impactful change for operating assets comes from reinventing tradition and reimagining existing workflows. To make this possible, we are working with leading organizations such as Rocketmine and their clients to bring all of this information into the immersive HoloLens experience, enabling them to conduct trainings, plan shutdowns, talk to experts as they do their maintenance rounds. Here you can see a maintenance engineer accessing PNID documents and IoT sensors directly from the asset that is now digital twin. And all of the officers and work to knowing what is physical, what is virtual, beyond location boundaries, allowing you and your teams to increase asset performance and reduce operating costs to everyday use of trusted information. You have the same context everywhere in your HoloLens virtual environment, in your web browser, and also in the real, in the field. Now let's shift gears and take a look at industrial digital twins in the engineering phase. With PlantSight's cloud-native tools, we enable you to review design models with ease in a distributed environment. Here is a project that was kindly shared with us with one of our users. They're working on an extension of an existing plant, and here, without vendor lock-in, they can bring in and visualize together engineering models from Bentley Open Plant Modeler, ProStructures, Navisworks, and IFC. They can get a visual context from the laser scans, and then they can easily section and highlight parts of the model and share them with their teams. They're able to find information easily within the model. They can classify. One of the biggest challenges on large projects is finding accurate information. With PlantSight, because you have access to all of your engineering data from all of the engineering disciplines, you can not only visualize, but you can also interrogate this data of the entire find key assets of the entire plant easily use existing engineering attributes embedded in your engineering models. The next example I want to show you is of is of a section of a floating production system that one of our users is working on. What they tell us is that the cost and risk of an undetected design flaw increases based on where they are in the project's life cycle. With plant side, they can get easy and democratized access to up-to-date information. And now with our integrated iTwin XR technology, which is already in early access, it provides the users an immersive visualization experience both on-site by visualizing your 3D model in context of the real environment, and off-site in your homes and offices to review the design in real scale using our teleport and minimap functionalities. You can conduct comprehensive design reviews with internal and external stakeholders. Our digitized issue management systems, our services are integrated with this HoloLens experience as well. You can identify issues in real scale. These can be then marked up. You can add a voice comment. This information is then synchronized with the browser, and the same information is available in both the environments, which makes decision-making and tracking of changes really easy. Traditionally, what our users tell us is that they keep a lot of communication that happens about the design in separate Excel files, which are then shared across the teams. With plant sites integrated issue management system, you can easily mark up information, and then we provide extensive dashboards that you customize, which gives you not only a line of why your engineering work changed, but also a complete overview of all your historical engineering data as well. With PlantSite, you can also take these designs and for handle engineering operations. These can be extended for virtual commissioning exercises and for training staff as they prepare for operations. These virtual exercises help reveal preventable issues from the field, which ensures smooth startups and allows you to accelerate ramp up as well. And it also shapes weeks of delivery schedules and, of course, enables the team to provide higher quality designs. Inspections. So timely and well-planned inspections and maintenance activities are important for increasing the life of operating assets and also help prevent any incidents that can disrupt production and harm workers. Over here, you see some very common real-world inspection scenarios for offshore and onshore, and also in the oil and gas sector. The natural surroundings of an offshore platform are extremely corrosive, also dangerous. Combined with limited space and remote location, it is one of the most challenging environments for a maintenance engineer to keep all of the equipment on the platform operational and also safeguard the structure against corrosion. Similarly, flare systems, which are very vital in protecting petrochemical facilities and are sometimes the last line of defense against major incidents, require regular maintenance and checkups. Flare inspection and maintenance is often performed at extreme height and involves a lot of risk for people, ensuring that these key assets are well maintained and fully operational. Also, on large refineries and oil and gas facilities, monitoring and evaluating corrosion of piping systems and important assets is a daunting task. Detailed reality models with immersive visualizations can allow integrity engineers and fabric maintenance planners to inspect and maintain these assets more efficiently and thoroughly in a safe environment. Instead of having a reactive and task-based approach, they can now better assess what the facility looks like and also can schedule and execute effective maintenance campaigns. The companies that maintain these assets are looking towards advanced visualization and digital twin capabilities provided by PlantSite and its XR solutions to keep people out of harm's way, reduce personnel on board for non-wrench work, reduce the overall cost, risk, helicopter flights, and also increase the quality of work planning and execution. One such company is Collins Engineers in the USA that help and inspect and maintain not only oil and gas facilities, but also bridges, construction sites, and other infrastructure. And here they're going to share with us their story on how they're maintaining this critical infrastructure.
Now, today a bridge inspection requires expensive equipment. It involves high safety risks. It takes significant time and carries a high cost. In most cases, there is no digital history of that bridge. Some of our most advanced users are reimagining inspections through the lens of digital twins. In Minnesota, the engineering firm of Collins is leading an effort to fundamentally change how infrastructure is maintained and managed over time. With the reality drone capture, it's now possible for them to experience the virtual bridge in full detail, as if they were at the actual bridge. The difference, of course, is that they don't need to go hire a machine, they don't need to put on a safety harness or take a car to get there, and they don't need to close the bridge down to perform the inspection. They're looking to do the whole inspection remotely from anywhere. Here, take a look at the amazing level of detail you can see experienced through mixed reality. Now, once the user's in mixed reality, they can observe an issue or defect and mark it up with natural hand gestures. They can take a measurement, and the inspection can then be synchronized back with the digital twin, where the results are visible in the web browser. The full history of issues now time-stamped and logged for future users. So just to
Thank you very much, Mehreen. That was a really comprehensive presentation, drilled down into a lot of detail, various use cases right across various sectors, that I'm sure that everyone found that extremely useful. Okay, everybody, now it's time to turn to some questions. Please do keep your questions coming, by the way. So here we have one question for the audience, from the audience. If we have an asset we acquired from another operator, for example, and don't have complete information, how can you bridge gaps of known unknowns and, more importantly, unknown unknowns to create a true digital twin? Alistair, would you like to take that one?
Sure. I think it gets to the heart of many of the challenges our users have. You know, you have in an existing asset, you have the data that you have, and that is all you've got. Through information standards, and I highlighted in my presentation the value of an information management discipline. But through application of standards, it can help you to identify the known unknowns. But of course, Louise, you correctly highlighted there's a number of unknown unknowns as well. So they're the gaps that you don't know you've got. I think this is where it becomes very important to look at digitalization as a higher level strategy in the organization. And you need to embed the use of a digital twin into all of your operating processes. So one area that I would highlight where unknown unknowns come to surface is actually during some form of incident investigation or some form of desktop design review. And what that enables you to do is to take either a risk-based or as I say, an incident-based evaluation to identify where gaps in what you know about your asset, information gaps or information inaccuracies and such like contributed to an incident, or if not maintained, could contribute to an incident. And that proactive use of a digital twin, again, can save significant reputation loss and drive significant safety improvements early. So I would encourage everyone to look at the digital twin as a holistic part of your business operations.
Mehreen, would you like to add anything to that?
I think one of the key aspects when you're building a digital twin is taking stock of all the CAD data that you have available. I think what we encourage our users to do is bring in any information that they have, because just the ability to view everything together and bring everything in one place highlights gaps in the data. So I think that's something we encourage our users to do, regardless of the system that they've used to design those models. Also in the case of PNIDs, whatever information they have, that they bring it in.
Great, thank you.
Often as Maureen says, often the ability to aggregate information from multiple sources very quickly fills in the gaps that you might find just by looking in one place. And I think that's a really important point.
Okay, great, thank you very much. Okay, so we have another question here, asking for further information on environmental monitoring applications. Perhaps you could take that one, Mehreen. What systems and data sources have you come across when helping your users to implement systems? And I guess, of course, the environmental aspect is really coming to the fore now with climate change pressures.
Yeah, we do have, we have worked with users where we've created flood simulation models using historical and predictive data, predictive weather data. Very recently, we worked with Doosan, leveraging our iTwin.js platform. So the solution that we showed today is just a glimpse of what you can achieve with a digital twin using iTwin.js. You can really expand on the capabilities. So we recently worked with Doosan on their use case where they wanted to build a digital twin of their wind farm. And for a wind farm, bringing in weather information and other environmental data is key as they monitor the wind farm and the turbines for performance, and also react to any power outages or temperature changes as well. And of course, in that case as well, weather forecasts are key when they're building predictive models to predict, for example, the power yields for upcoming days as well. So that's one example where we worked with Doosan with environmental modeling.
Great, thank you very much. Alistair, anything to add on that?
I think we've seen people use the digital twin at the project stage in some pretty interesting ways for that as well. Everyone's very familiar of the CO2 impact of things like large areas of poured concrete. And the approach we've taken there is we've put calculations into our iModel engine and our iTwin services that enable you to measure the CO2 impact of things such as concrete volumes, steel weights, and such like that contribute to the major elements of a design. And again, very much like Josh highlighted in his video, where they were looking at layout, comparing layout options, flow line choices, construction cost, etc., in a very simple way. We are for the first time able to bring in measures such as CO2 impact of various different design alternatives, or various different, at how that design, the CO2 intensity of an engineering process is changing over time. And I think that insight, giving it ready and real-time access, is enabling engineers for the first time to truly bring decision-making about the environmental impact into the engineering process, and in a transparent way, weigh up and select design options based on that potential environmental impact. And I think that's a huge, that's how we're going to engineer our ways out of our CO2 dependency and challenges. And I think that's a huge opportunity now for all engineers in the industry.
Great, thank you very much. Okay, another question here. This is on asset management. Can you maybe expand a bit more on asset management through the digital twin and your applications for that, Alistair?
Sorry, Louise, can you say that again?
Sorry, it's a question about asset management through the digital twin.
Right, yes. Sorry, I was just trying to type an answer to that question as well in parallel. Yes, so I'll just cover that one fairly easily. We see that occurring in two directions actually was what I was busy putting into words in the type box. The first is being able to incorporate information from your maintenance management solutions, your maintenance history, your location breakdown structures, your equipment and spares, for example, information into the digital twin. So that's sort of contributing to building a more complete picture. But I think what we're going to see over time is the bigger impacts will come from people who are using that digital twin either to plan their maintenance. So, for example, being able to look at a particular location and see where other, use a 3D visualization, maybe from a context capture or reality mesh, so no engineered model, overlay on it future work in that same area and spot where maybe they can, an operator can do 2 or 3 pieces of maintenance in the same area at about the same time. But I think there's also a very significant safety opportunity here as well, where we can see and we can apply visually, pull together the information from a model, pull together information from the maintenance management system and the control of work solutions to ensure that at the time the work is actually being undertaken, that A, it's been done in the right place, that there is an extant work permit that's all approved, that any procedures for tag out and lockout have been fully executed and have been signed off, and ultimately that the safety and the risk analysis around undertaking that work has been fully carried out. And that way we can really move the needle on ensuring that the work is done safely and completely and as well as it can be done. And I think there's a huge benefit there.
Great, thank you very much. Okay, another question. How do you normalize data from monitoring systems, and how do you handle huge data input from automated data acquisition with high sampling rates? Alistair, do you want to take that one?
Yeah, I'm happy to take that one. So I think there's a number of strategies we employ there. We have got users who are loading truly vast quantities of data into our solutions, very, very high speed or large volume and high speed ingestion. That our largest user actually is continuously monitoring their rail geometry for a railway in an entire rail system spanning a lot of continental North America. And that continuously being surveyed as trains just run over it, and that information is being loaded accurately and continuously. So that really is vast scale. Every few inches along a track, we're getting readings. So we adopt a number of strategies. So again, depending on what you're monitoring, you can ingest real time, and then you can apply algorithms to it to derive meaning from it. The most common types of work we're seeing there is performance trending. So a good example may be the efficiency of a heat exchanger. You're looking at build up inside it, and you're achieving that by measuring pressure across pressure drop across the heat exchanger. You're not really interested in the instantaneous measures. What you're interested in there is the trends over time, and a gradual change could imply build up and a need for cleaning, for example. So we're applying numbers of techniques, whether we're working with standard historians and SCADA who are outputting averages to us on a daily basis or an hourly basis, going all the way up to integration where we're taking the real-time feeds, loading and applying very much more advanced analysis on that to spot anomalies and detect problems.
Okay, great. Thank you very much. Mary, did you want to add anything on that?
Yeah. So the use case that I just mentioned earlier, Dusan, in that scenario, what we leveraged was the Azure Digital Twin. So all of their IoT sensor data was streaming to the Azure Digital Twin, and then using the Azure IoT Hub, we were able to stream all of that information with near real time, with a maximum of 5 seconds delay in our iTwin viewer, so that they could see analytics and also monitor their turbines in a visual interface as well. So yes, we do have cloud technology now available to us that can help ease the burden of monitoring and getting all these high frequency data from the sensors in the field.
Great, thank you. Okay, I think we have time for maybe one more question. To what extent can AI contribute to decision making? Can AI take decisions independently in industrial processes? Alistair, would you like to take that one?
I think we're heading towards that. I think we're seeing SCADA and control systems already adopting AI and maintaining a model not just of a local environment, but maybe of the entire process. We've done work with others around bringing in not just, if you like, the local asset process performance, but other factors such as maybe electricity cost, the time of day, demand forecasting, and beginning to aggregate those numbers to help, in the first instance, support decision making and present information. But for sure, we will see AI making decisions automatically. And I think that's just a natural progression in the scale of those decisions, from small local ones to larger macro decisions. I think will just grow. We'll see those grow over time.
Thank you very much. Maureen, anything to add on that?
Yeah, just to add to what Alistair just mentioned, having an AI tool as part of your portfolio with integrated with your different systems is like having a very fast learner on your team. So these models can get trained on historical data, and also then just like you or would in an informed environment take that decisions for you and also predict hypothetical events, any alarm conditions, and these really help you to react to situations that might happen in the future. So yes, we're already seeing a lot of AI applications within our digital twin technologies as well. You saw the AI and ML capabilities for PNID recognition. Similarly, we have these predictive models built into our analytics tools as well that help with decision making and also improve over time as well.
Great. And maybe we just have time for an hour. Okay, I think we maybe out of time. Okay, I thought we had one more.
There was one more, Louise. It was just a simple one. The AI that Maureen showed in there that's learning the symbology of the PNIDs to make them much more intelligent. That is part of our iTwin services. It's not provided by a third-party toolkit. It's developed by Bentley has a AI center and that's focused on AI and machine learning techniques, and that is a development from that team.
Okay, great. Thank you very much for clarifying that one. Well, ladies and gentlemen, it just remains for me to thank our speakers. And we've had 3 great presentations, really covered all the hows and the whys and the wherefore of digital twins. I'm sure our audience will have taken a lot away from those presentations. So thank you to Bentley Systems for this webinar, and thank you to our speakers, and also thank you to our audience and for all the questions. So now we will wrap up, and I hope you have all enjoyed the webinar. Thank you very much.
Thank you, everybody, for the time.
Thank you.
Hello, Louise. I think everyone has gone now, apart from us panelists. Oop, attending.